So, going back
We still have 2 minutes.
to the last problem that we had last time. So I'm just going to put it back. Maybe it's a little bit different number, but I'm just pulling this from my notes. So again, we were talking about substitution method, and this method is for the composition. So when we look at the function, the first thing we have to pay attention if we have the composition. If we have it, then probably we have to go with the substitution. If we do not have composition,
I don't know where my roll is.
and we have to see if there are some other methods, maybe simplify, maybe change, maybe split, something like that. But here the main thing for this example was not to really look at the substitution, but actually after substitution you still have x to the 4th left. And we cannot have x and u at the same time. Also, we have to remember that x is still the variable, but it's hidden inside of u, so you cannot just pretend that x to the 4th is a constant, so maybe you can take it outside. It's possible. You're gonna do it. Main thing here, you have to decide how you're going to take care of this x to the 4th. And here we had to go back to the substitution and then solve for x squared. So this is what we get right here. And then we have to square left and right side, and that's how you get x to the 4th. So basically looking back at the substitution and trying to manipulate the function, changing a couple things. And again, as I said last time, it comes from the experience. The more you practice, the better you will be with these problems. By just observing or knowing the theory behind doesn't help at all. You have to work, you have to see what functions you may get, and then getting through will help you to understand the concept and process. So those examples, again, I cannot show you all of them that you have in the book, just some. What we're going to do right now, we're going to go to definite integral, and then we'll come back and do a couple of problems with indefinite integral again. So let's take a look. So for example, and this will be number 5. Okay. So for example, we have integral from 1 to 2 dx over 3 minus 5x quantity squared. Alright, so the first thing. Yeah, I just realized that. So the first thing, since we're dealing with the definite integral, you have to remember the second fundamental theorem of calculus. And the theorem started with if f is continuous on the closed interval. So every time when you see definite integral, you always have to check if function is continuous. That's important. You will see this with the next example. But I have to check this. So here's my question. What is the domain of this function that you're looking at? Right, so domain here will be x does not equal to 3/5. And then I go and check my interval, and 3/5 is not here, so that means I'm okay and I can proceed. Okay? So the next thing, how do I take care of this problem? Well, we have to do the substitution. Because there's no such thing, again, in my mind, I'm kind of looking at the list of antiderivatives, for example. Or in section 5.4, if you go back, let's say, go to the ebook, and in section 5.4, they have a list of integrals, which we say antiderivatives. So there is a table, kind of, but it's not the full one, 100% complete, but the basic ones. are there. So you will refresh, and you have to constantly kind of to keep the table in front of you until you will get acquainted with the integrals and you feel okay, like I can recognize, I can see it. So again, that's section 5.4. Go to ebook and you will see that table, and I think you even can print it if you want. Now you cannot use it on the exam, I can tell you this right now, but when you practice while you're working, you can use it. So here I have to go with the substitution, and remember we are talking about composition. So my inner function most likely is the substitution. So what is my substitution here?
3 minus 5x.
So u equals 3 minus 5x. Again, I said it yesterday, sometimes we can pick the wrong substitution. So if you try to use substitution and it's not leading you to anything, then just quit. Go back and think, is there any other ones that maybe I can pick, maybe I can use? So the next step, du over dx, we take in the derivative, so we get negative 5, and then we need dx. So we have du over negative 5. Now, I'm going to tell you something else. I'm extending this line, meaning there's something else will happen. Now, what will happen is this. If you look back at the original problem, you have the variable x, right? That means your x is sitting between 1 and what? 2. Now, you change this integral, and we'll substitute in a moment. You change this integral to everything with u. Okay, do you understand? So let's continue, but we'll see what's going to happen. So we have integral, we have okay, let's do it this way. So dx, right? What is dx? Du divided by negative 5, that's dx, right? Right here. And then I divide by what?
U squared.
U squared. Well, that's not what normally I'll put, but let's do it. So we have integral du, we have negative 5 u squared. And we understand that negative 1 over 5 can go outside. And then you have just du over u squared. Okay, let's just pause for a second right here. Now, I hope you noticed that I didn't put upper and lower limits. And the reason I didn't do it because that's what I wanted to tell you. Since you had x here, x was between 1 and 2. Now you have everything in terms of u. So that means you have to change your upper and lower limits. They cannot be the same. Again, now it's u. Okay, now it's integral in terms of u. 1 and 2, they are not from that u variable. Okay, it's with x. So what do you have to do? You have to change upper and lower limits. So how do we do this? We basically say this. If x is 1, then u is what? Negative 2, right? What do? You take this 1, substitute into your substitution, right? Get negative 2, good. If x is 2, then u is what? Negative 7. So your integral is from negative 2 to negative 7. So you have to remember this. Finding antiderivative works fine, but if it's a definite integral, you must change upper and lower limits. Don't forget that. That's the most common mistake, to keep the same. You can't. So we have negative 2, negative 7, negative 2, negative 7. Now, some of you may say, well, can I flip the integral? And the answer is yes. And maybe some of you would like to do this because negative 7 is smaller than what? Negative 2. But overall, I can tell you this, it doesn't make any difference. Normally, we change the integral just for the convenience. For example, like right now, for example, I have negative sign, right? So if I flip my integral, I will have negative. Negative, that makes it what? Positive, right? That makes it positive. But I know the antiderivative right now. What's the antiderivative of this?
1 over u.
With what? So I'm going to rewrite this one more time just to show you what I have, so this will be u to negative 2 du, right? So the antiderivative to this one is what?
1 over u.
Will not apply it. What's missing? Not 1 over u. It's what? It's negative 1 over u.
Oh.
So, oops, I put 4, not 4 by u. Okay, so 1 over u, and then goes from negative 2 to negative 7. And let me say this again. The reason I didn't flip upper and lower limits, because I knew that antiderivative will be negative. So now negative and negative over here gives me what? Positive. But overall, let me say again, if you feel like you always want to have smaller number on the bottom, that's fine. Then just move upper and lower limits, make it positive, and just continue. So overall, it doesn't make any difference if you change it or not. So I have 1 over 5 times by 1 over u, just positive. Okay, negative, negative gives me positive. And then we have from negative 2 to negative 7. Again, it doesn't make any difference if you flip. You'll still have the right answer. So 1 over 5, and now we substitute. I have negative 1 over 7 minus, according to the theorem, negative 1 over 2. Substitution is important. Careful with the signs. So I will have 1 over 5, and inside I have negative 1 over 7 plus 1 over 2. So LCD will be 14, and I get negative 2 plus 7, which is 5. So the final answer will be 1 over 14. So what was important? Well, the substitution is important, but also, again, since this is the definite integral, we have to change upper and lower limit to make sure it works with u. If you forget to change upper and lower limit, then everything else will be wrong. Now, the other thing is, if you kind of remember what happened yesterday, remember when we used substitution, everything was in terms of u, but then we had to go back to x, right? Remember? Since you started with x, you have to finish with x, right? Well, here you don't have to do it because you already changed your upper and lower limit. The only thing what you need is just your antiderivative and then substitute changed upper and lower limit. So for a definite integral, you do not have to go back to x. Do you understand? Okay, let's take a look at one more. One more definite integral. So this one is a simple one, but there's something special about it. So we have from negative 1 to 2, and we have dx over 2x minus 1. So when you start with the first step, speaking about domain, remember you cannot ignore this. Speaking about domain, what will you get?
X cannot equal 1/2.
Okay, so what that means for us?
It means not possible.
It's not continuous.
So if you look, right, the function is not continuous on this interval. Do you understand? And even more, when we say not continuous, we're really talking about infinite discontinuity, right? Because 1 over 2, x equals 1 over 2, is our vertical asymptote, right? Because it's a rational function. So in this case, if you know the function is discontinuous on this interval, then you don't have to do any work. What you have to say, you just have to say that the answer is does not exist. But that requires you to check for the domain. That's why it's important not to ignore this. Okay? We have to do the problem. But we have to be smart too. So if I check for the domain and I know there's something wrong, I have vertical asymptote, so I know I have no integral. Now, again, if some of you have to take Calc 2, then this will be expanded in more kind of theory there, so some integrals will exist. But I'm not going to talk about that because that's not the topic right now. But overall, if function is discontinuous on this interval, then the answer does not exist. You don't have to do any work. But you have to tell me this. Domain, x does not equal to 1 over 2. We know that this number is here, so it does not exist. You cannot just put that does not exist. And I really want you to learn this way. The more you explain, the better you will be. When you're trying to pretend that, okay, I'm going to put the answer and then teacher will guess like what I really thought at this time, that's not going to happen. Your paper is the evidence. If you have your work, I'm looking at your work. If you don't have the work, if you have just the answer, that's a completely different story. Okay? Even if your answer is right, the first sentence when you look at your test, it says you have to show your work. So learn how to show your work, even if maybe you're not confident, but try to go through the process and explain. And here, I only like to see domain. You say that this domain, x does not equal to 1 over 2. I know what you're thinking about, and does not exist will work. But just putting does not exist like this will not work for me at all. Why? Because again, let's take a look at the calculator, and you will see the calculator actually telling you what we have.
$2.
So,
And actually doesn't.
going to the calculator, okay, well, yours will send a message too. Let's see if it's going to, well, hopefully we'll get some. So we have 1 over 2x minus 1. So we're going to graph this. And we know we have, barely can see, right? And you guys cannot see here, but I cannot turn on the screen because the battery died, so. But you have your calculator so you can see. So you see there's a vertical asymptote, okay? We can zoom in, that's not the problem, okay? We can zoom in. And then let's try to find that integral, right? So we'll go to second, we'll go to trace, which is calculate number 7. It will ask about lower limit, which is -1. Then ask about the upper limit, which is 2. And then we're going to hit enter. And it's going to say what? What do you have in your graphing calculator? What does it say? Are you getting any results? No, what is saying? Any messages that you can see? So what did I get? I got,
It's saying error divided by 0.
and Minico can see it. Obviously, I have error message, and it says divide by 0. Right? So there's obviously something wrong. So your calculator is telling you there's something wrong here. Okay? So you use your calculators, okay? Get the hint, but make sure you explain. So that's why, again, going back to this problem, that's why it's important for us to check for the domain. And this is a very simple problem. You know, I wish every problem was like this. Check domain, it doesn't work, I say it does not exist, and we're done. Okay, it's a very simple problem overall. So the previous one, we checked for the domain, everything was fine. We had to go through the substitution. Also, we had to change upper and lower limit and finish the problem. Here, I have to do absolutely nothing. Here's the answer. All right? So let's take a look at one more. Definite integral. And this one is integral from -pi over 4 to pi over 4. And we have x cubed plus x to the 4th times by tangent of x dx. Alright, so since this integral also is the definite integral, so I have to check for the domain, right? Am I going to have any problem with this function? on this interval. What do you think? What if I ask you this? What's the domain of this function? All the numbers? Can I substitute any numbers into tangent? No, right? And let's make it smaller. So where tangent has problems, don't go too far. At pi over 2 and what?
Pi over 2.
And negative pi over 2, right? At least from the left and right. And obviously then more and more, right? Because tangent has lots of different class limits. Okay, we know this. Now, but you should not be confused because again, if you don't know what tangent is or are confused about the graph, let's say, well, think about tangent as what? Sine over cosine, right? So where's cosine equals 0? At pi over 2, negative pi over 2, right? So this function is not continuous everywhere, right? It has problems. But question, is this function continuous on this interval? And the answer is yes, right? Because pi over 4 is a little bit smaller, okay? So this function is continuous on this interval. So that's one thing. So we know we cannot put does not exist, okay? We know that we cannot put does not exist. But what else you can pay attention to, that you have symmetrical interval, right? Can you see that? So you're from negative pi over 4 to pi over 4. Or you have negative 2 to positive 2. Or you have negative 1 to positive 1. Okay? So if you see definite integral, everything is okay with domain, and you have symmetry, then you have two outcomes kind of that you can look at. So one of them is, well, yes and no. Okay, but let me explain, not just the answer. I don't care about the answer right now. I need the theory. So what we can have here, we can have two outcomes. Well, actually three, but two specific ones. So let's take a look. So if your function, we talked about this before more. If your function is odd function, that means the function has a symmetry about the origin. So this will be our odd function. Then look, if for example my integral from negative 1 to 1, let's say, so this is a little piece and this piece over here, remember we talked about area under the curve? So what do you think we'll get?
0.
We'll get 0, right? Because these pieces are the same except one positive, one negative. So if we have symmetrical interval, and your function is odd function, I'm going to put it like this. I know it's not very nice to put it this way, but I'll put odd dx. So function is odd. Then you know the answer is 0. So that also will not require specific work to find the integral, okay? But still you have to show me that function is odd. You cannot just look at your calculator and say 0 and say 0 on the paper. That doesn't work well.
Do that.
You have to explain, huh? What?
I didn't just type it into my calculator. It's pretty. You asked me what the output on side is equals 0.
Well, how do you know that was 0?
I know what the graph of tangent looks like.
But remember, it's not the tangent, just the tangent. It's what? X cubed plus x to the 4th tangent. So it's not just the tangent. It's not just the tangent. So we cannot just look and say. And I understand, well, you had the right guess, okay, that's perfectly fine. But we cannot just say, okay, it looks like. We really have to know if it's even or odd. And we can graph, for example, to look. So, again, guessing is good, but sometimes you get the right answer, but with the wrong work. So careful with this. And the other thing here is when we have, let's say, even function. So I'll put the parabola here, okay, but this will be even function. So even function has symmetry about the y-axis, right? So if you think about this, let's do it again from negative 1 to 1. So I have this, and I have this. So what would you say if I have integral from negative 1 to 1 of even function? So what would you say? Do you get 0? No, but what you can do?
You'd say it'd be twice, it'd be like 2 times whatever even is, right? 2 even?
Right, that's good. And so advantage having even function is that you can double it, but you don't go from -1 to 1, you go from what?
0.
From 0 to 1. So having 0 is basically great help because it's easy to substitute. So when function is even, we don't get simple answer like for odd 0. It's not the case. But at least we have a little bit easier way out with the integral going from 0 to 1, but just double. So do you understand? Now, if you have just some function, not even or odd, like neither, okay, well, then you have to do it. So the question is right now, going back to our integral, what do I have? Do I have even? Do I have odd? Or I have neither? Okay? And one thing, maybe just to add to this. Well, sometimes, let's say you have a function and you actually go through the process, you're working on the integral and you get answer 0 and then you go like, oops, I spent all this time and the answer is 0, so could I see this from the very beginning? You know what I'm saying? But for this function, specifically what I put over here, it's very difficult to find antiderivative. It's more calc 2. But I really don't care at this moment, okay? I just want to check if I have even or I have odd. If I have odd, who cares? The answer is what?
0.
0, right? So let's check if I have odd function. And we talked about this before. It comes from precalculus. How do we check if function is odd or even? What do we do? Remember we talked about this in class.
Function.
So we take the negative x and substitute for every x. So I have negative x cubed plus negative x to the 4th. Then I have tangent of what? Negative x. And if you decided to do this on, if you, let's say, look at your calculator and your calculator said 0 and you're saying, oh, I'm guessing this is odd function, you actually have to do this to prove that function is odd function. Again, I will not give you credit if you just put 0 without explanation. And you cannot say function is odd because I'm going to ask you, how do you know? If you're going to say, well, I look at the calculator, that doesn't count. You really have to prove that function is odd function. So this is how we do it. This will be what?
Negative x cubed.
Negative x cubed, right? Negative x to the 4th is just what?
X to the 4th.
X to the 4th. But what is tangent of negative x?
Negative tangent of x.
Negative tangent of x. Tangent is odd function. And this comes from precalculus, okay? From trig. So overall, what do I have? I have negative x to the 4th tangent of x. So this is positive, and the negative goes up front, that's why I have it negative. You understand? And then what I have to do, okay, first of all, I substituted, I kind of simplified. Well, this function right here, obvious, it's not your what? Original, right? So that means you don't have even function. But the question, do I still have odd? So what we do here, we factor out negative sign, and we have x cubed plus x to the 4th tangent of x. And what do you see? This one is the original function. So as the result, you got negative f of x. And that indicates that you have odd function. And when you show me all this process right here and you prove that this function is odd, you can just go and say it's 0. But just putting 0 will not count. And you can put this right now into your calculator and see what you have, and you will have 0. Because the function, this function that you're looking at, is odd function. Now what I'm going to do right now, just to show you a good graph, because if you put this into your calculator, it looks awful. Okay, it's not very good picture. So what I want to do right now, let's graph it just to prove a point. Okay, it's not going to be the best graph that we can think about. So we have x cubed plus x to the fourth, what is my fourth, and times by tangent of x. So if I graph this, so this is what we get, okay? It doesn't look good. Like, really, what else do I know? I see like vertical lines, okay? But if I do zoom 6, like normal window, it doesn't give me anything. Look, then only obvious at 0 I can see the symmetry, right? Can you see the reflection? Huh?
Is it?
Well, I know, but remember I said paradigm, so I cannot push. You can use your calculator, okay? But then, obviously, it doesn't help to look at the Desmos. I cannot show you. Well, Minical will see it, but you will not. But what I mean relate the piece, okay, of the graph around 0. So I see it's odd function. So one more time, when we check it for even odd, here's your odd. That's the result, negative f of x. So again, you substitute negative x inside, you simplify, and then you factor out negative. Even means when you substitute negative x, you will get back your original function. It will be exactly the same function. So please remember this. This will help a lot. So like I said, knowing that you have a problem with the domain helps a lot because no much work has to be done. And also knowing that I have odd function on the symmetrical interval, then I have the answer 0. So these things we have to look for, and we have to be very careful. We cannot just ignore. If I get even, well, it helps a little bit, but not a lot. Okay, it's just little help that I will look for, but not too much. So please don't forget these examples. They're kind of main concept examples. Everything else is just do the work. Okay, but these. Again, checking for domain, changing upper and lower limits, don't forget. Also, even and odd will help a little bit. Odd is a great thing to have. Even, just make it a little bit smaller. So, that's about definite integral. Let's go back and work with indefinite integrals. So, I'm going to show you a little bit more complicated substitutions. Okay, a little bit more complicated problems. It will not be obvious, kind of like when you look at the problem and you feel like, okay, I know what that is. But eventually you will see and you will recognize those substitutions as long as you practice. So here's the example that I want to show you. This will be example 8. And we have integral x to 9 over 1 plus x to 20 dx. Let me give you a couple seconds, okay? I'm just going to be quiet, and I want you to think about substitution. Like what you will put in. This problem cannot be solved without substitution. Okay, I'm telling you this right now. So think about this. And since I have indefinite integral, the picture doesn't help you out. Yeah, somebody's trying to whistle elevator music, right? Or we can play, the Jeopardy music, right?
Yeah. He's enjoying it. Some noises that are just weird. Back with singing the
I was like, I recognize that or something.
Well, any thoughts about substitution? Right or wrong, it doesn't make a difference right now. So what do you think? What is your substitution? I'm just going to say yes or no.
Yes.
X to the 20th?
No.
X to the 9th?
No.
Would you use the whole thing?
No.
1 plus X to the 20th?
No. right?
1.6.
So, well, see, now it's a little bit complicated to look into this, right? But it's this one a little bit more complicated. Here's my question: do you see inverse tangent here
No.
as your antiderivative? And you may say no, and that's okay. Remember, you're learning, so I'm not expecting from you to see this right away. But let me change this problem. So this you will be facing doing your homework assignment. We have to deal with more complicated substitutions. Not obvious. There are not too many of these kind of problems, but still, there's some in this section 5.5. So here's my change right here. So here's the question. What is my substitution? X to the 10th. That's right. Yes. So u equals x to the 10th. That's my substitution. Okay? So it's difficult to see it because it's hidden inside. It's not obvious. So du over dx will be 10x to the 9th. And this will help me to get rid of that x to the 9th on the top. So dx is du divided by 10 over x. Divided by 10 times x to the 9th. So challenging, okay? But if you see in the example, you'll do something similar on your homework assignment. I actually took this from the homework assignment, except you will have different powers. So x to the 9th, here we'll have 1 plus u squared, right? And here we'll have du over 10 x to the 9th. So canceling these, that's the main goal. And then moving 1 over 10 outside, what do we have? We have 1 over 1 plus u squared du. And this one, if you go with antiderivative, it's your what? Inverse tangent. You have to recognize this. I know we did inverse tangents a couple of times, but it's just one of those. So we have 1 over 10, and we have inverse tangent of u. That's what antiderivative is, and that's from the list of antiderivatives from section 5.4. And plus c. Don't forget, this one is the indefinite integral. And then I have to go back and substitute x to the 10th and plus c. And this will be the answer. Here's the question. Can you prove that this is right?
If you take the derivative, right?
Can you? That's right. So I really want you to do the same thing on the exam. That you find your antiderivative, you find your indefinite integral, and then you take a derivative just to see if you can get this.
Can you have done it without having to substitute?
Huh?
Can you just you don't have to substitute if you
This?
use the substitution rule?
You have to. You cannot do this problem without substitution.
Would we learn how in pre-calc? Just like calc 2?
Huh?
Would we learn how in calc 2 too?
Well, I mean, as a process, no, you have to go with the substitution. There's no other way to go without. Can you see like you saying no? What do you see?
You just think through, it'd be, you see that the one on top is 1 less, but it doesn't have the 10 in front of it, so you know it'd be tangent inverse x to the 10th divided by 10.
You have to do it.
You have to do
It seems like easy right now. You will see when you get to the problem. But that's right. You just take the derivative of this, right? So you get 1 over 10, 1 over 10, and you get what? 1 over... Actually, let's take the derivative just to see how it goes. Because you still have little problems before with the test. So if I take derivative of this, and what do I get? I get 1 over 10, right? And then this is the composition. So I take derivative of the inverse tangent first, right? So there will be 1 over 1 plus what?
X to the 20th.
So I'll put it like this, x what? 10th to what? Second, just substitution, right? And then you still take the derivative of the inside, which is what? 10 x to the 9, right? So these will be canceled, and we have x to the 9th over 1 plus x to the 20th. And that was our beginning, right? Okay? So, can I recognize those formulas? Now, I'll show you another one. It will be almost identical, okay? Just to make sure you see the same concept, but with different functions. And this one is integral of sine of x over 1 plus cosine squared of x dx. And as I just said, it's the same thing. So what do you think your substitution?
Would be cosine x. Would you?
That's right.
You can do simplify
I know you can't.
the sine squared.
No.
Or,
Here the formula says what? Sine squared plus cosine squared equals 1, right? If I would have minus over here, minus, then yes, that would be easy to simplify and cancel. That would be nice. Not here. So I'm looking at this from this point of view. So I took this cosine squared and put it like this. So we can see the substitution here is u equals cosine of x. Then we have du over dx, which is negative sine of x. And dx is du over negative sine of x. So that's what we have. And when we substitute, we have sine of x over 1 plus u squared. So you see we're going into the same direction that we had before. It will be negative sine of x. So canceling these, moving negative outside, we have integral 1 over 1 plus u squared du. And again, it's that's what? Inverse tangent, right? So we get negative inverse tangent of u plus c, don't forget c, and then put the substitution back. And that's the answer. Okay? So again, this is a little bit more complicated. But don't forget, take the derivative. It doesn't take long to take the derivative, as long as you're going to get it right, okay? That's what I'm saying. But it's the best if you take the integral and then you take the derivative and see if it's the same. And remember, I'm only talking about indefinite integral, right? So now let's take a look at another one. And this one is, well, I looked, it's in your homework assignment, but it's also kind of a little bit interesting for an integral. So let's try. I mean, okay, you're facing this problem, you're trying to do it. And again, there's no such thing like this in that list of formulas, again, of integrals. And for example, if you decide to take 1 plus x squared and move it up, that doesn't help, okay? Just put it to negative first power. And what else we can do here, I don't see anything that we can just simplify and make it smaller for normal process. The only thing here, you kind of have to go with the substitution, okay? But if you try to go with this, like 1 plus x squared as your substitution, what will be the derivative?
2x.
2x, right? But you don't have just 2x on the top. What do you have?
1 plus.
1 plus 2x. So you will not be able to cancel. Do you understand that? That 2x. If you take, for example, 1 plus 2x as your substitution, then if you take the derivative, you'll get only 2. So this one will sit, right? It doesn't go anywhere. So what that means, if you're kind of trying and still not working, it doesn't mean you don't know what to do. It's just a little bit more complicated problem. And what you have to do here, remember we said, what if this is the substitution? Then when you take the derivative, you'll get what? 2x, right? But here you have 1 plus 2x. So what we should do, for some examples, somehow we have to separate this. You have to get rid of it. Just to have what? 2x. And when I say to get rid of it, I don't mean you just can't cancel it. You're not going to cancel it. But what you can do, pay attention. You can do this. You can take this function, what you're looking at right now, this rational function, and you can split this function into 2 pieces, like this. 1 over 1 plus x squared, and 2x over 1 plus x squared dx. So now you have 2 functions instead of 1. Can you do anything with the first one? So you will have this one. Integral 1 over 1 plus x squared dx, that's the first one. And then you have integral 2x over 1 plus x squared dx. Right? So do you know what this is?
That's just inverse tangent.
So you've seen it 3 times, I think it's okay right now to know what that is. Okay, so this is easy, now you know what this is. Okay, what about this one? Now you should tell me what to do, right?
Substitute 1 plus
You go with the substitution as 1 plus what? X squared, right? 1 plus x squared. And if you take the derivative, you will cancel 2x. So what I'm going to do here, I will separate this. Normally when we have 2 integrals, and you cannot just put the answer right away for both of them at the same time, you work with 2 of them separately. And we say like I1, that's this one, plus what? I2, that's this one, and then you work with I sub 1 separately, okay? This is just a name, okay, nothing else. So I sub 1 will be integral of 1 over 1 plus x squared dx, and this will give us inverse tangent, very simple one. Now, you can put plus c, that's not a big deal right now, okay? Nobody will be, let's put it this way, I'm not going to take any points off if you start calculating these integrals separately, because at the very end when you pull them together, that's when you put plus c. Do you understand that? Right now it's fine, but if you put plus c, that's still okay, but then you have to put plus c for another one. So if you put it, fine. If you don't put it, that's okay. We can put it. But then if you go with the second one, you have 2x over 1 plus x squared dx. That's where you go with the substitution. So u is 1 plus x squared. So du over dx will be 2x. And then we have dx equals du over 2x. So we have integral 2x over u times by du over 2x. So canceling these, right? We have integral of du over u, and you should know what that is. What's this?
natural log.
It's a natural log, but again, careful with the natural log, okay? You cannot just say natural log. What do you have to say?
Absolute value.
Right, you have to say natural log of absolute value of x, okay? You cannot put it without absolute value. So this one is natural log of absolute value of u, and again, put plus c, but remember, we're not going to have 2 plus 2 c's, it's just 1. And then you go back, and I'm going to put equal sign here and finish at the very end over here. So what do I have as the answer? I have what? Inverse tangent of x plus. Now, one thing I didn't finish here, okay? I apologize, I didn't finish. It's natural log of what?
1.
Absolute value of 1 plus x squared, right? Now, one thing right here, we put absolute value, okay? That's how we're supposed to do. But look inside. Do you get any negative number here?
No.
No. So if you know for sure you don't get any negative numbers here, you can get rid of absolute value, you can put parentheses, okay? But as a precaution, please put all the time that absolute value, there's nothing wrong with this. So I'm going to keep it, and then you get the 1c at the end, and that's it. So that's the answer to this problem. See, so not just the substitution, but also I split it. Also, I splitted the integral in order to get to it. So that's, again, a little bit more complicated than just simply putting something in and substitute. So what time do we have? What time do we have?
3:05.
So we're almost done, right? So that's this. Now sometimes, and let me just start the problem, okay? And this will be the last one. We're not going to look again. So sometimes we have problems like this. And this, if you look at this one, you may say, okay, I can think about this problem as this. And you may say, okay, my substitution is what? U equals sine of x, right? Because it's an inner function, you know what I'm saying? But when you take the derivative, right, what do you get?
U squared over cosine x.
So you get what? Over cosine of x, right? But when you substitute, you have integral, you get u squared times by du over cosine of x. You understand? And really, what do you do after this? Well, you go back to this, right? And what's going to happen? So that's not the right way to do it. So I'm finishing. I need 1 more minute. I'm not going to finish it, but at least I will start. So to overcome this problem, you have to use identities, but not 1 minus cosine squared. You basically go back to the same thing like this. What identity we have to use here in order to proceed is this identity. The sine squared of x is, and there's another identity as 1 minus cosine of 2x over 2. And this is dx. This is what we have to use here for the substitution, okay? Well, I should say substitution, as identity. Because sine squared of x equals to this. And then, finishing with this, you're going to split this, and you will have this like this. 1 over 2 minus cosine of 2x over 2 dx. And from here, you will have two integrals, 1 over 2 dx, minus, I'm going to pull out 1 over 2 from here, and you will have cosine of 2x dx. And the second integral over here, it's a very simple substitution. What is the simple substitution here? U equals 2x and we'll finish. Okay, I'm going to stop over here, okay? But as you see again, I have to use special identity to split this. This one is easy, right? It will be 1 over 2x as antiderivative. And here's also an easy one, but I'm saying about substitution. Substitution here will be u equals 2x. And that's how we finish it. So substitution involved, but we cannot apply it right away because we don't see it. First we have to simplify using identity and then to finish it. So please practice. Don't wait for the last moment. Please start working on these. If we're not stopping, okay, we get to 5.5, then we're finishing with 5.5 today. Tomorrow maybe I'll pick up one example, maybe finish this one, I don't know, okay? But then I'll move to 6.1. So it's not like I have time for you to go and spend some time and kind of relax. There's no time for this. So please, again, keep working every day. You know, your assignment is not due tomorrow. Alright, so we'll, like I said, do maybe 1, maybe 2 problems tomorrow, and then I'll go through sections